And this final video on volcanism is going to focus on where volcanoes are distributed globally and how they relate to plate tectonics. When we're looking at our planet, we'll see that most of the volcanoes are found along that ring of fire, that area around the Pacific plate underneath the Pacific Ocean, where we have lots of subduction occurring, because this is an area that's mostly a convergent boundary, where the Pacific plate is being pushed underneath these continents, where it will eventually melt and form chains of volcanoes along the ring of fire. But in addition to the ring of fire volcanoes, we see that we also have a good number of volcanoes along our divergent boundaries, along those mid-ocean ridges in the middle of our oceans. And then finally, we have just a handful that are just absolutely randomly distributed. Places like Hawaii, where we have a hot spot, where the volcano is not located along the boundary of a plate, but instead is found in the direct middle, called an intraplate volcano. So this diagram is showing us all the different types of volcanism that we can see around our planet. Starting off at the image in the upper left, here we see an oceanic plate, the Pacific Ocean, being subducted underneath another plate. Here, as it subducts, once it reaches 100 kilometers in depth, it will start melting. That melted magma will come up to the surface, forming a chain of volcanoes, which we know here as the Aleutian Islands. On the bottom left, we can see another form of subduction, forming a continental volcanic arc, where we have a chain of volcanoes sitting on top of the overriding continent. Here on the upper right, we have a mid-ocean ridge, which is a divergent boundary releasing lava at the spreading center, where it's separating and creating new crust between the two plates. And in the bottom right, we're looking at Africa, where we're looking at a rift valley forming at a divergent boundary on top of a continent, where magma is coming up as the continent is being ripped into two. And then finally, on the left center is where we see one of those intraplate volcanoes, the ones that's not forming from convergent or divergent plate boundaries, but instead is found in the middle of a plate. And generally these happen from something called a hot spot. And these hot spots are going to be a true sign of intraplate volcanism. With a hot spot, we have a large plume of magma coming up from the mantle, rising towards the surface. Think about lava inside of a lava lamp coming from the bottom and quickly rising towards the top. But when we have this magma plume reaching the surface where we live, it's going to create a flood basalt. That magma is going to escape, and because it's generally mafic in composition, it's going to create a really thin but wide covering layer of lava that's going to cool down into basalt. But over time, the plate on top of that hot spot will move. Hot spots are stationary. They always stay in one spot. But the plate is going to move on top of it. So it's going to form other large flood basalts that eventually, if they get tall enough, will become volcanic islands. And all of this we can see in Hawaii.